Welcome, everyone. Thanks for joining me this afternoon. My name is Jason Ehrlich. I do the business development duties around here. And you know what? I'm going to start this presentation by saying it has been a while since I've talked to a black plastic box. I'd much rather talk to live people, but we will endeavor. Again, thanks for joining in. Looking at the attendee list, it looks like we have our normal eclectic bunch of consultants, some architects, some reps, and I think even some end users and employees have snuck in the game. So we will try to keep this thing kind of right down the middle as far as being technical. And we probably should have everybody out of here in say 15 minutes, if you can, depending on the questions that we'll get to at the end. Before I get into that, let me do my obligatory company commercial since we do have some new people joining us. If you're not familiar with Kinetics Noise Control, I say our biggest claim to fame is that we make more acoustic products than anybody else in the world. Whether we are doing the topic today, treating sound quality inside of a space with room acoustics. We have a big organization around here that just concentrates on keeping noise going through floors, walls, and ceilings, keeping the rest of the building nice and quiet. We have a whole division that's dedicated to just keeping equipment vibration from getting into the building, as well as controlling things for seismic activities. We have a rather large product offering in our industrial divisions. And as you can see here in the commercial airflow, we can handle big air movers and louvers as well. And of course, all this technology tends to find itself down to the home group, so we can do some amazing things for single family residential and home theater type applications. I think if we look at room acoustics, which is what we're going to talk about today, that breadth of product is there. I think we now do officially have the widest amount of products out there. We're going to talk about Woolf today. We have a whole clean lineup, which is our PET panels. We have both kind of a broad range of reflectors, as well as very specific wood ones that can deal with specific frequencies, a full range of different types of fabric absorbers, a whole category of clouds and baffles to choose from. We have specialty noise control tiles to treat areas between rooms, and we can even do perforated steel and aluminum panels. And again, as a last kind of commercial, if you go to our space and you're new to the design world, we have some spaces pages, and you can kind of see we have auditoriums, music, education. And if you click on one, it's a really good guide, kind of a beginner's guide of the types of products you might see. For this example, in offices, this is from the page itself. You can look at these products. You can also kind of get little educational boxes that pop up. So it's a really good starting point. If you go to the homepage, click on the room acoustics, kind of scroll down, you can get to the spaces. So with that, thank you for indulging me. We'll get into what is Woolf. Most of you listening in are probably familiar with this product category. I did some internet sleuthing and saw that it was at least introduced back in 1949, if not earlier. It's been around a while. But what Woolf is literally wood fibers bound in cement. And because you've got these open porous things, it does have some acoustics. Maybe if I pop up a close-up of it, you might recognize this product. As I said, it's been out on the market for a while. Of course, you know, being Kinetics, we're going to put our own little spin on it. And one of those spins is we're trying to keep it really simple on our website. We try to put it in broad categories. And the first thing I'll say is if you don't see it on there, if there's an option you're looking for, give us a shout out. We can probably do it. The images you're seeing on the screen now come right from our brochure on our website, so that's available for download as we speak. But basically, we kind of put these things into some categories, starting with direct mount and walls. In this category, we can do panels up to 4 foot by 8 foot in 3 different thicknesses, 5/8, 1 inch, 1.5, and we can do a bevel or a squared edge. We have a whole section on acoustics today, so we'll get back to that here in a bit. Moving from wall to ceiling applications, that same direct mount that I just mentioned that we can do on a wall, we can also do on a ceiling. In addition to that, we can do clouds or baffles, and again, we can do those up to 4 foot by 8 foot. The thickness on the clouds or baffles is limited to 1.5 inches because we need the stability of the panel to do that. And again, we will talk about acoustic performance at a bit of a length here in a bit. So we have the direct mount, we have ceiling clouds and baffles, and the last broad category are tile, and lay-in ceiling grid. You can put these panels, they can be cut to fit the 2x2 or 2x4, placed right into a ceiling grid, as you see in the picture. For those of you who are a little bit more familiar with us, we are working to make this part of our quiet tile lineup. We're just right now kind of checking our calculations on the weight to make sure it's going to be suitable for most of the grids out there. As far as options go for these particular products, you can get them with we call it the groovy lines. We're offering them in diagonally, right or left, as well as horizontal or vertical lines. Again, if you don't see it on our website, reach out. We can probably do it. It does come in 3 different finishes. You can get it raw, which is intended to paint it in the field, chalk, which is white, and wheat, which is it's a natural looking finish. And you really don't want to just put raw panels up. You might not see much of a difference to the naked eye between the raw and the wheat, but there is some slight discolorations in raw, and that's where we go in and put a light coating of this wheat finish to make it have that natural look. One thing we can also do is kind of add an edge to that panel, which lets us put mineral wool behind it. And as we'll kind of see when the acoustics, you do get a big bump. But again, we're going to move into that here in just a few slides. As far as vital statistics go of this product category, it's made from poplar wood. Believe it or not, once you add the cement to it, this kind of blew me away. The smoke developed when we did our fire test was 0, and the flame spread was 0. I was kind of shocked by that, but nope, 0 and 0. That's as Class A gets. We can do this with FSC certified poplar. So if that's an option, that's what you want to do, we can make that happen. And because this is a pretty natural product, it's going to be declared, it's going to be red list free. It decomposes naturally at the end of its cycle. And of course, it's formaldehyde free, unlike a lot of the fiberglass products out there. And lastly, it did pass the California Clean Air Test. So VOC free. This is a very clean product that you can put in for absorption. So I am going to kind of kidnap the presentation a little bit to talk about acoustics. Those of you who know me know I'm on a bit of a mission to educate the design community on NRC. I find that when I'm doing AIA presentations, that's probably the most accepted and understood term, at least by the design community. But when I start peeling away the layers, you can kind of see it's not always grab the biggest NRC number and put it in a room. It's a little bit more complicated than that. So if you will indulge me, we'll do a bit of a dive here on acoustics. The first thing I want to kind of point out that NRC doesn't necessarily mean quality acoustics. And what do I mean by quality acoustics? Well, I mean anytime there's music present, anytime there's anything other than a voice. Like, you know, a dog kennel requires acoustics. It doesn't necessarily require quality acoustics is where I'm going with that. And hopefully this will make a little bit more sense. As I show these frequencies here, humans can hear from 20 hertz all the way up to 20,000 hertz on the high frequency side. And if we kind of look at the human voice range, the fundamental frequencies of which when we speak and sing is in this range right here. And then you get something called voice harmonics. That's a very complicated and deep subject, but basically if you're speaking at 100 hertz, there's going to be some movement of air at 200 hertz, 300 hertz, 400 hertz, basically doubling wherever that fundamental frequency is. It's kind of the reason why a violin sounds different than a piano. It's how our ears hear. It's a fascinating subject, but a little bit past what we're going to talk about today. To give you an idea, right there is middle C at 262 hertz. And when we look at that piano, you can see a very, very wide frequency range that it can play to. But when we plot NRC on this graph, you can kind of see we basically are taking these 4 points and averaging them out. So you can see right away, if you're doing anything with music, you're going to probably fall outside of this NRC range. So you could have a really, really high, really, really good NRC number and not necessarily have good acoustics in the space, even with voice frequencies, which is where this thing's kind of targeted at. But you know, male voice can get down all the way down to say 80, 85 hertz down there. So a lot of your basic products will treat a little bit under that range, but the point of showing you this graph is to show you that, you know, NRC does not necessarily equate to anything when it comes to music. Another issue when we look at acoustics is testing. Let's start out and just kind of look at that PET product line. Everybody likes the bright, pretty colors. They come in a 3/8 inch thick panel, and you know, you say the word acoustical, and then everybody says, "Oh, it's an acoustical product." Well, it's only 3/8 of an inch thick, and one of the secrets of acoustics is if you want to get some of those lower frequencies, the panel does need to be kind of thick to deal with the size of the wavelength you're dealing with. When we look at the sound test for this 3/8 inch panel, you can kind of see, as you might expect, it's really, really, really good at high frequencies and then drops off really, really quickly. So I would not necessarily call this a good product. Its NRC number is down here at 0.30. It's not necessarily a good product. It's pretty. It looks good. It probably would tame a hotel lobby a bit, but I wouldn't necessarily want to use it in even lecture halls, and certainly not music spaces and auditoriums. Another factor of acoustic testing is how is it mounted in the laboratory? Most of the time, most of the testing you're going to see is what's called A-mounted, and you're seeing a picture of that on the screen. In fact, that is the 5/8 inch Woolf panel being tested. It's 72 square feet of material. It's right in the middle of that lab floor. And when you see an NRC number, more than likely it was mounted in this A-mounted style, and that's what that test is giving you. So when you see an NRC of 1.00, it's literally 72 square feet of material put in a laboratory. It doesn't tell you specifically what frequencies. It doesn't tell you how much to put in a room. It literally is, that's the test. That's what you're looking at. When we look at the test for the Woolf panels, you can kind of see, as you might expect, they're going to do really well in the higher frequencies, and then that cement is going to reflect back some of those wider wavelengths back into that space. Again, not a great NRC at 0.45. Then when we look at different ways of mounting, I'm going to take that same panel right there and I'm going to put some airspace behind it. And that's that same exact product, that 5/8 inch thick Woolf panel, and what's called an E400 mounting. And it just simply means that there's 400 millimeters of airspace behind this panel. And this test is designed to simulate what a ceiling tile would do, because you would have airspace typically behind that ceiling tile. So you have to be very careful when you're looking at tests, because when we look at the results and we compare it to the one we just looked at, it's a significantly different curve. And that's the only difference between this and the other product, is that 400 millimeters of airspace. So when we kind of compare all these curves at once, you can kind of see that it does make a big difference on how they're mounted. The bigger problem, this is a bit of an aside, is when you see things like baffle testing. For years and years, you're going to get some crazy numbers, because how do you test a three-dimensional panel? You really can't just put that in the middle of the floor and call it good. And so when you see these baffle testings, they're in what's called type J mounting, and you get some crazy high numbers. And people try to do an apples to apples comparison out of ignorance between the A mounting and the J mounting. The good news is Eric Wolfram, who runs the Riverbank Acoustical Laboratory, sits on a standards committee, and they've actually tackled this literally this summer. It's just come out, and there is a new array classification for baffle testing, and Kinetics is going to partake in this, and basically so that we can get apples to apples comparison when we look at these different products, that's now available. I did put the web link in here. All of you watching in will get a copy of this, a video of this. So if you really want to get into the nuts and bolts of how acoustic testing works, you can go ahead and type that link in and follow it. And in case maybe you thought I'm just stretching the importance of all this, I want to show you a room where we plotted the difference. Same size room, same building materials and everything. The only difference in this room is one had carpet and one had hardwood floors. And what you're looking at is what's called reverb time, T60 time. And that's simply if someone claps, how long does the sound take to decay 60 decibels? And you can see we have from 0 seconds up to 3.5 seconds, and from 62.5 hertz up to 8,000. What you're really seeing is that the carpet, which is this green line, is already removing all this high frequency energy out of the space, where the wood floor, it's bouncing back and entering the room. So basically, if you took some of those products that only do high frequency absorption, they're not going to do a whole lot for a room with carpet because the carpet's already doing it. And that's why this all matters if you need quality acoustics. And that's where Kinetics is going to reach into its fiberglass library, because you can kind of see by these different profiles, we can tune the room based on the building materials that are in there. And even something like this particular product, our VTLF, our Versatune low frequency, has a very small NRC number at 0.35. But if you look at the frequency ranges, we're down here at 40, 50, 100, 125 hertz, where these are cutting off at 100, and that's where it works. It's actually quite an amazing product to get this kind of performance at big wavelengths at only 2 1/8 inches thick. So, you know, I call upon you to at least reach out to your local representative, reach out to us if you're in the design community. If you've got something where it's music sensitive, at least let us help you talk through this conversation, see if we need to get you in contact with an independent consultant to get that design to work as it should. For those of you who are listening in that might have seen my AIA presentation, this is a slide from this. This is a competitive product, and I kind of put it in because you can kind of see the difference in performances between an A mounting, a D mounting, a C mounting. That just means it has absorptive material behind it or some airspace behind it. But you can kind of see you really don't get good performance in that A mounting configuration until you get down to 2 inch, and you still only get a 0.60 NRC. I promised that we put a little twist in our Woolf product, and here it is. Our fibers are a little bit more open, and what that means to you is that at 5/8 inch thick in an A mount configuration, we had an NRC of 0.45 compared to 1 inch at only a 0.40. So if you are specifying a product out there that is 1 inch thick, you can save yourself some money and some space by going down from a 1 inch to the 5/8, or even our 1 inch is better than the 1.5 inches. Our 1.5 inches is better than the 2 inch. So that is something that's available to you. Again, our fibers are a little bit looser. That bumps that NRC up a little bit, and it does actually lets us make the same NRC performance or better in a thinner panel. I mentioned that we can put mineral wool behind it, and when we kind of look at those numbers, you can see that same 5/8 inch panel jumps up to a 0.85, so we're getting it pretty significant on the NRC range. A 1 inch with 1 inch mineral wool 0.90, and a 1 inch with 2 inch mineral wool 0.95. So we can't get there. Again, just keep in mind that NRC is more of that voice range. It doesn't necessarily equal good quality music acoustics. That's what I'm going to leave you with. Okay. Lecture over on acoustics. Let's get back and finish up our talk on the Woolf panel. When we talk about installation, this is the direct mounted, or if you're going to use drywall grid to put a little airspace behind these panels, you simply just screw through the face of the panel into the media behind it. Here you see with a wood blocking with an airspace behind it, and here you see with drywall furring channel, same idea. Simple, easy. Not really much of a challenge, just as long as you follow our screw patterns and the installation guidelines. Here you see a cloud panel. They're going to come to the job site with a groove cut in them, and then you can just simply use a drywall channel, standard available commercial drywall channel, slide it in there and hang away. For the baffles, what we'll do is we're going to take a 3/4 inch piece of PVC, cut it to the width of the panel, and insert it so that you can use your wire rope, hang it by there. In this configuration, we are limited to 2 foot by 4 foot max size. I know we went a little fast. It really is a straightforward product. The website is live right now. It is kineticsnoise.com/wolf. I'm going to leave this slide up. If you need pricing, if you need more information, you can start that journey at sales@kineticsnoise.com. And with that, I will kind of watch the questions link here. If you want to type in a question, I will do my best to answer it. Getting a question of point and origin, they will ship out of Ohio. Lead time, that's hard to answer because we can custom paint them, we can glue. That's really going to be on a case-by-case basis. I think that's the best answer I can give. Sorry. Well, I appreciate everybody being nice to me on my first public webinar in a long, long time. Well, if there's no other questions, again, you will get a copy of this at some point, I think within 24 hours. So we can reach out to that in sales@kineticsnoise.com. With that, I appreciate everybody listening in, and thank you for your attention.